Hello, everyone. This is to continue chapter 3. We're going to start with the process termination. So last time we have talked about the process creation, and we have seen that when a process is created, it gets its resources from the parent based on one of three models. The first model is the very generous parent that will, give whatever that parent has. It will share it with the children. The second model is a generous parent, but not that generous. So the parent would share part of what it has with the children. And the third model is the parent that would say, I'm not going to be sharing any resources with my children. Whatever I got, the way I got it, the children will go and get theirs as well. Whatever I got is mine. That would be the third model. And I said that based on the situation, one of the three is going to be followed. Okay, so it doesn't happen that the operating system would adopt one of them all the time. No, it doesn't go this way. Okay, so at any point of time, one of them is going to be picked based on the state of the system. So now we're going to be talking about the termination. So here, the process executes last statement. In our case, it could be something like the return or the closing curly bracket. Okay, and then asks the operating system, so the process asks the operating system to delete it using exit. And we have seen the exit system call in C, right? Sometimes you say, if certain condition, then exit -1 or whatever, right? So you actually call it. All right. So when the process terminates, okay, it calls exit, okay, or it asks the operating system to terminate it using exit, okay. When that happens, it returns status data for from child to parent. So it goes through the tree towards the root, okay, via the weight. And that's very important. Okay, that's why I told you, if you don't use weight, you're going to end up having either a zombie or an orphan. The process resources are deallocated by operating system. What does it mean to be deallocated? Taken away. Okay, for the process to die, for the process to get terminated, the resources have to return back to the resource pool for it to be able to be used by other processes. Now, the parent may terminate the execution of the child. Really? Yes. How? Using the word abort. It's not a word, it's actually, a system call as well. Abort. So we have now an exit. That's when the child finishes execution and the child wants to, when the process finishes execution and the process wants, to terminate. So it calls for the operating system to, kill it using the system call exit. But also, the parent can force the child, okay, to terminate using abort, okay? So what is the difference between exit and abort? Exit when the process itself wants to terminate. Abort when a process wants to terminate another one. Which one? Anyone? No, one of the sub tree of children, okay? Now, why would a parent do that? Why would a parent terminate a child? We have one of three possible reasons. The first one, if the child exceeded allocated resources, what does it mean? The child has used all the resources that is allocated to that child, and it still needs more. It still needs more. We will see that in chapter 7. So in this case, the child gets terminated because, it will keep asking for resources, and the parent cannot really afford that kind of need of the child. So now the parent will abort the child. The second one is, if the task that the child is created for, so as an example, you created the child to calculate the sum of from 1 to 100. That sum you already have. So you don't need this child to proceed the execution, okay, or to continue the execution, and that's why you can actually terminate it, okay. So if the task assigned to the child is no longer required, okay. The third one, if the parent itself is exiting. As I mentioned many times, the parent should not exit while the children are still executing. All right? Most operating systems do not allow this. They do not allow a child to continue if its parent, terminates. Why? Because this could end up having either an orphan, most probably an orphan, or, of course, a zombie if the parent works a little bit before it gets terminated while not waiting for that child, okay? So if the parent terminates while the child is still executing, we will have an orphan. I got a very smart question from a student in U1, Obada. Yeah, we have here children, tree like that. So the question was why? Why is it bad for the parent to terminate without terminating the children? Why is it bad? Look at that. Assume that I'm going to be terminating this one. So this one is going to be killed. See what happens to the whole subtree now? It gets disconnected. Right? It looks like you can imagine it literally as a tree, right? So when you kill this one and without having to terminate this one, those are kind of lost in memory. Okay, what's wrong with that? Each and every one of them is assigned resources. So let's say this has resource 1, resource 2, this has resource 3, this has resource 4, and so on, right? So when you do that, those resources will never get deallocated, right? Which will cause a problem in dealing with the resources and resource allocation. So now here, some operating systems do not allow child to exit if its parent, to exist if its parent has terminated, as I mentioned before. So how does this work? If the process terminates, then all its children, okay, must also terminate. That's what we call cascaded termination, okay? I call it the domino effect. When you have these dominoes put side by side, and then you push one of them, all of them get affected, right? This is the domino effect. I call it domino effect. OS expression is cascaded termination, okay? So for the parent to terminate, its children will terminate. For each of the children, it also has children, and so on and so forth. So the whole tree will terminate. The parent process may wait for a termination of a child process, okay, by using wait. This is system call. So we have seen 3 system calls so far for the termination: exit, abort, and wait. The call returns the status information and the PID. Look at here, PID equals the wait. We in our code we passed null, as we are not really interested in the status. You see here, you send the status call by reference. Why? Because you will read the status of the termination and get it out. So it's a call by reference. Okay, so this object will change, right? Will change in the wait and come with the information of the termination. If you're not interested in that, we just pass null, right? And that's what we do in our example, okay? If no parent is waiting, okay, so it did not invoke wait, all right, the process is a zombie, okay? If the parent terminated, okay, without invoking wait, then the process is an orphan, as we have mentioned. So the process did not wait for the child to execute, okay, then the child is a zombie. When is it a zombie? When the parent is still running, eh? As soon as the parent terminates, okay, while the child is still running, then the child becomes an orphan, okay? So it's either a zombie or an orphan. Which means that the possibility of the process to be a zombie, it's kind of there. I mean, the process becomes a zombie and then an orphan, right? If the parent is not waiting, then, it could be a zombie before the child could be a zombie, before it becomes an orphan, right? Okay. All right. Now we're going to be talking about the inter-process communication.